In this next section, Video 3D, we're going to talk about triangle congruence. And I'm going to go off to the side here. I'm going to draw this triangle. I'm going to draw one that looks like it's the same. And you don't really need to draw these over here, just watch. And suppose I put a single arc here. So those angles are the same. These angles are the same. And these angles are the same. Sides the same. Sides the same. Sides the same. Because all angles and all sides are congruent, I would say triangle, and just watch so you can. I would say triangle ABC is congruent to, and then I'd have to make sure I match the correct spot. So A is the one with a single arc. I'd grab single arc angle P. B is double arced, so I'd grab double arc angle R and then S and make sure I put the triangle in front of it. And I'd say those triangles are congruent. Notice on these triangles though, I made all 6 pairs of corresponding parts congruent. 3 pairs of angles and 3 pairs of sides. And in the next couple sections, we're going to discuss that it's not necessary to prove all of the 6 are the same. If you can get some of them to be the same, the rest will fall in naturally. So the first congruence theorem we're going to have is what we call SSS. And what SSS stands for is the side, 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 makes sense, triangle congruence theorem. And what it says is if you can get all 3 pairs of corresponding sides congruent, the angles will get locked in for free. So perhaps you have a picture like this and you have another triangle and these look like they're, actually mine don't look quite good. I'm going to fix mine a little bit so they at least look congruent if I'm going to talk about them being congruent. What the side, side, side congruence theorem says is that if this one is the same length as this one due to markings, and this side is the same length as this one, that's really all I need in order to say those triangles are congruent by side, side, side. And you might be saying, yeah, but you're missing the third S. Because this is shared, we know that it's got to be the same length on both of them. So my brain can add that to the picture without it having to be specifically marked. That's actually a theorem. It's called the reflexive property. And it says, you know what, if you guys share an angle or share a side, it's obviously got to be congruent to itself. It's kind of silly, but it is. And so I would say that these triangles are congruent by side, side, side. And if it said, how do I know? 2 sides are marked, and the third one is shared. So triangle WQP is going to be congruent to, and again, I have to put it in the correct order. W will go with S in this scenario. SQP, and I would say by the side, side, side congruence theorem. So if you can get 3 sides the same, either they're all marked, or your brain can add one to it because it's shared, then you can say that the triangles are congruent by side, side, side. The next one is the side, angle, side. So let's write that down. This stands for side, angle, side, triangle, congruence theorem. And what it says is that if you have triangles that appear to be congruent, and you have markings indicating that this side is the same as this one, this side, just a minute, I got a beeper that my thing's running out of batteries. All right, I'm back in business. Sorry, my Bluetooth was running low. I had to hook it up here. So, and if this side was the same, then I can say these are congruent as long as the included angles are marked the same. So it has to be the ones between these two sides. So be careful on the worksheet. There's some, I'll show you in just a second. Let's finish this one up. So I would say these two triangles are congruent, and if it asked me why, I would say by the side angle side congruence theorem. But make sure it's the included angle. So off on the side here, which you don't need to put down, make sure if it goes like this and it goes side angle side, and this one goes side like that, you can't say those are congruent by side angle side because this isn't the one included between these. It'd have to be this one over here. So just be careful what markings you get. Otherwise, it's a fairly easy one to use. So next up on the next page. State if the two triangles are congruent. If they are, state how you know. Well, on first appearance, this looks like I got myself a case of side, angle, side. But when I go over to this one, it goes side, angle, and then not the other adjacent side. So I would say no, there's not enough information based on what I know right now. If this pair had been right here, I'd be good to go. Nothing. The next one down looks like I've got one pair of sides right here. Then I've got another pair of sides right here. That's not enough. I need the third pair, but the third pair is shared. We'd say the reflexive property allows us to say that this is obviously congruent to itself, and it's shared by both triangles. So I'd say yes, and then I'd say by side, 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 triangle congruence theorem. And the last one down here on the bottom, what do I have on this one? It looks like I've got two pairs of sides. So just one second here, I'm going to scroll this down. So it looks like I've got a pair of sides, which is good. I've got the S going right here, right here. I've got an angle going right here, right here. Do I have the other adjacent side so I can travel along and go side, angle, side, side, angle, side? And the answer is yes. I can mark this one because it's shared. We call that the reflexive property. So I'd say yes. There's enough on here by the side, angle, side, triangle congruence theorem. And I know when you were doing this first semester, you wrote some proofs for this. We are just going to be determining if they're congruent. We won't be writing formal proofs. So in number 11 and number 12 on here, it's a screenshot off your worksheet. It says state what additional information is required for you to use this theorem. So let's go look at what we have. If I want to use side, angle, side, first of all, I've got to have a pair of congruent sides. That's good. I then need an included angle. So it depends on where you want to go. Suppose I say, well, okay, I'm going to say angle H is congruent to angle G. And again, I only need one letter because that vertex isn't shared. If I'm going to do that, then I have to make sure I go side, included angle side. Side, included angle side. So then I would need these marked. So in order for me to use side, angle, side, the additional information I need is number one, I'd need to know that angle H is congruent to angle G. So I have the angle going. And then I need the other adjacent side. So I'd also need to know that side HJ, I'd have to put the bar over it, has to be exactly the same length or congruent to side EG. And then I would be okay by saying these are congruent by side, angle, side. Now let's look at what else I could have done. Or, and you would only need to do one case on your worksheet, or if I was going to do this angle in here, so I could have side, included angle, side, then I need this pair marked over here. So, or I could have said I need angle. Now I can't call that angle I because angle I is shared by two angles. So I'd have to say angle HIJ would have to be congruent to angle GIE. Let's go mark that. HIJ GIE. And then in order for me to do side, angle, side, I have to walk along that and make sure I do side, included angle, side. So I'd also need IJ segment congruent to side, angle, side, IE. So there's two ways you could have done that one correctly. And last up on here, number 12. In order for me to do side, angle, side, again, it has to be the angle included by these so it helps to draw them. I would need to have angle L congruent to angle H, and then I would be good to go. And those are our first two, side, 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 angle, side. Our next two up for discussion, our next two triangle congruence theorems, they're called, are the angle side angle and angle angle side. So let's split this like this. Angle side angle is exactly what you would think. It's when you have an angle, an included side, and an angle congruent to an angle, an included side, and another angle. Just make sure, go ahead and circle this, that this is the one smashed between the two angles under question. So I'd say these two are congruent by angle, included side, angle. And our last one, angle, angle side. So this goes angle, angle, non-included side. And if my markings on the next triangle were angle, angle, non-included side, then I can say these are congruent by angle, angle, side. You'll notice there's no angle, 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 and here's why. Watch. Suppose that's a right angle, and let's suppose this is 45 degrees, and this is 45 degrees. Let's go make another one. Just make one that's obviously way smaller. Still 90 degrees right in there. And I'm going to say this one's 45 and 45. Let's say they're both halves of squares, so they have all the angles the same. You'll notice this blue triangle right here is way smaller than this red one. Angle, angle, angle is not a valid congruence theorem. So which ones do we have right now? We have side, side, side. If you can get all the sides locked in, you get the angles for free. We have side included angle side. We have angle, included side angle, and we have angle, angle, non-included side. So last up, state if the two triangles are congruent. If so, state how you know. Well, I can see I've got some angle, angle going on. So I either need to get a non-included side or the included side. Well, always add your brain to the picture. These share a side right here, and it's included between the angles. If I were to walk around here, I'd go angle, included side, angle, and likewise on the other one. So this one is angle, side between them, angle. So this would be yes. Right, yes by angle, side, angle. The next one, what do I have here? I have one side, I've got one angle, and nothing else. Can my brain add any more sides to the picture? Not because they look congruent, but because I definitively know they're congruent. And the answer is no, because they don't share any sides. However, in here, I've got a pair of angles I can add to the picture. And why can I do this? Why are these congruent? And if we were writing a formal proof, we'd say those are congruent by the vertical angle theorem. They are vertical angles, and therefore, we've already said that those angles on the crisscross on the scissors have to be congruent. Is this enough? What do I have here? I've got angle, non-included side, angle, side. So I do. I have angle, angle, side, which is a valid congruence theorem. So again, your process is you take the markings under consideration and then you add your own brain to the picture. So on this one, I'm going to take the markings under consideration that I've got side, 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 side. So I do know I have SS. Can I get the third side and make it be SSS? The answer is no. They look the same, but they're not marked the same and they're not shared. Can I get an included angle so I can do SAS? And again, the answer is no. Although they look the same here and here, they are not marked, they're not vertical, they're not shared. There is no other way for me to add for sure any other markings. You can't go by looks. So I'd say, nope, not enough info on this one. And then, similar to the last questions on this, it says state what other information is required so that I know these are congruent. So let's do that. How can I get angle, side, angle on this one? So it says you have to, I can't right now, I'd need more markings. What would I need? I would need a side pair, check. The angle on one side of that side and the angle on the other. This would be an angle, side, angle congruence. And it's not the only way to do it, but that's how I would opt to go with this one. So what information would I need? I would need this side congruent to this one, so I'd say QD would have to be congruent to ED. That would give me the side. I'd also need the other angle, and the side has to be smashed between the angles, so I have to go with this one, not the other pair. All right, so angle, side, angle, I would need angle Q congruent to angle E, and that would do it for me. And lastly, angle, angle, side. So I've got angle, angle, another pair, another pair. And now I need a non-included side. It doesn't matter which of these two I pick, but I can't do that one because that would be angle, side, angle. So I got to be careful. How about we just say this one, the one by the double arc, congruent to that one. And I'd have angle, angle, side, angle, angle, side. So all I'd need for this one is that XZ would have to be congruent to LN, and I would have it. So we're done. You should stop here. You're going to do worksheet 3.8, 3.9, and 3.10. And 3.10 is a combo of 3.8 and 3.9. And on 3.10, you can do the odds only. On 3.10, do the odds only. Have a good one.